Multiple choice questions. Now let's start some multiple choice questions. Those were asked in your previous entrance examinations. This one is part 1. We will deal about 50 questions here, and in another part another 50 questions will be solved. The number of millimoles of HCl required to neutralize 10 ml of 0.2 m sodium carbonate is, this question is asked in MOE model questions. We have already discussed number of gram equivalent of acid is equal to number of gram equivalent of base for the complete neutralizations, right? Then I have already discussed about this formula, right? You have to remember this formula. Weight in gram of acid by equivalent weight is equal to normality of base time into volume in milliliter by 1000. Just put the value. Weight in gram of acid divided by 36.5. 36.5 is the equivalent weight of HCl. Here is HCl. What is the equivalent weight of HCl? 36.5. Molecular weight by basicity, and molecular weight is 36.5. Basicity is 1 because here is only one hydrogen is present. So 36.5 is equal to 0.4 into 10 by 1000. Where is 0.4? Here is 0.2, right? 0.2 molarity means 0.4 normality. We have to put normality here, right? How? 0.2 molarity is equal to 0.4 normality. Here is one relationship between normality and the molar. The molecular weight of sodium carbonate is 106, right? 106. And the equivalent weight is 53. How 53 is obtained? 53, right? This 53 is the equivalent weight and 106 is the molecular weight. And if we divide molecular weight by equivalent weight, then 2 is obtained, right? And 2 times the molarity is equal to the normality for sodium carbonate, right? How 53 is obtained? Molecular weight by 2. Why 2? We have already discussed about the calculations of equivalent weight of the salt, that is molecular weight divided total charge. How many number of charges are present? Sodium only one positive charge, then 2 into 1 positive charge means 2, that is either total charge in cation or either total charge in anion. So molecular weight divided by 2. So total charge either positive charge or negative charge, that will be 2. Then 106 divided by 2 is 53. So 53 is the equivalent weight of sodium carbonate. And if we divide the molecular weight by 53, then 2 is obtained, so that the normality is 2 times greater than that the molarity in case of sodium carbonate. That's why 0.4 is obtained here. Into 10, 10 is this, and divided by 1000 is according to the formula. And we have already discussed about the relationship between number of moles and the weight in gram, right? Number of moles is equal to weight in gram divided by molecular weight, right? Divided by molecular weight. Then weight in gram is equal to number of moles times molecular weight. So number of moles of acid times molecular weight of acid divided by 36.5 is equal to, and molecular weight of acid is 36.5. This 36.5 and 36.5 will be cancelled out. The number of moles of acid will be 4 millimole. So answer will be B. Remember, this question is very important. Next question. 100 ml of 0.5 molar H2SO4 and 0.1 liter of 1 molar HCl. The normality of the resulting solution will be. We have to calculate the normality. And here is the formula for the calculation of these numerical questions. So N1 B1 plus N2 B2. N1 is the normality of H2SO4. B1 is the volume of the H2SO4. N2 is the normality of HCl, and B2 is the volume of HCl. Then 100 ml. So we have to put 100 in case of B1. Right? Then what is the normality of H2SO4? 0.5 molarity of H2SO4 is given. Then we have to convert this into normality. We have already discussed about the relationship between normality and molarity. Normality into equivalent weight is equal to molarity into molecular weight. That is, molarity is equal to molecular weight divided by equivalent weight times the molarity. And what is the molecular weight of H2SO4? That is 98. And what is the basicity? That is S2, means 2 number of replaceable hydrogen. So basicity will be 2. 98 divided by 2 will be 49. So 49 is the equivalent weight. And if we divide the molecular weight by equivalent weight, then 2 is obtained. So the normality will be 2 times greater than that of molarity. So 0.5 into 2 will be 1. So 1 is written here. Then this 0.1 liters will be converted into milliliter, that is 100 into 1 molarity. So 1 molarity means 1 normality in case of HCl, because number of replaceable hydrogen is equal to 1, that is basicity is 1, molecular weight by 1, so equivalent weight is also equal to molecular weight. So answer will be 1 normal. Answer D. Very important questions. Pollution in atmosphere is measured in, right? It is measured in ppm. You have to remember this. This question was asked in IOM 2018. Right? Next question. Right? Volume of sodium carbonate to neutralize 1 liter of 1 normal H2SO4. I think this question is incomplete, because the question asked about the volume of sodium carbonate, right? And the strength is not given. Then how to calculate this, right? So if strength is given, then normality equation is useful for the calculation of volume of sodium carbonate. However, there is no any strength. So if the question is asked about the amount of sodium carbonate, then we have to solve that question on the basis of these questions. Then answer will be 106 gram. However, this question is incomplete, I think. Next question. Calculate the molarity of pure water. The molecular weight of pure water is equal to 18, right? Then gram molecular weight will be 18 gram. And we have to use the density concept to calculate the molarity of pure water. 1 gram per ml is the density of water. It means 1 ml of water weighs 1 gram. Then here is a formula for the calculation of molarity. Then weight of water in gram is equal to 1 gram according to density concept. 1 gram per ml means 1 ml of water weighs 1 gram. Then weight of water will be 1. Then gram molecular water 18. Then 1000. Here is 1000 according to the formula. Then 1 means 1 ml. Here is 1 ml. So 1 gram of water occupies 1 ml volume. That means 1 ml of water weighs 1 gram. Then 1 by 18 into 1000 by 1. This is 1 ml and this is 1 gram. Then answer will be 55.55 molarity. Then pure water means it is pure. It does not contain any other type of the impurities. Means the density of that water should be 1 gram per ml. So density of that pure water should be 1 gram per ml. So we have to use the concept of density to calculate the numerical problems of this type. This is very important question. 55.55 molar is the answer. Strongest base and the weak acid indicator is, right? The salt formed by the combination of strong base and weak acid will be basic. Remember this, right? The salt will be basic, right? Because the base is strongest. So which one is strongest? Base. So salt will be basic. In case of basic salt or basic medium, phenolphthalein is used as the indicator. In case of acidic medium, methyl orange is used as the indicators. And the phenolphthalein has the pH range 8.2 to 10. It is the basic range of pH. So phenolphthalein is used in case of the basic medium, because the salt formed by the strongest base in the weak acid will be basic in nature. And phenolphthalein is a weak organic acid. It is generally represented by SPS, and it is weak organic acid, so it undergoes the reversible reaction HPH H plus PS minus. And in acidic medium, the color of the phenolphthalein is colorless, right? It is colorless in acidic medium. However, its color changes to pink in case of basic medium. Now let's start. How does phenolphthalein indicate the basic medium by changing the colors? I am going to explain about this, right? In case of basic medium, OH minus is present, right? OH minus is present. Then this H plus minus combines with OH minus ion to give water, so that the concentration of H plus ions in the right hand side of this reversible reaction will go on decrease. Then according to Lee-Chatelier principles, the directions of that equilibrium shifts from the left to right. That is according to the concentration change from high concentration to low concentration, because the concentrations in this right side will go and decrease due to the formation of water by the combination of H plus and OH minus in basic medium. So the color will be pink, or in case basic medium. In case of acidic medium, H plus will be present. Right? What happened in acidic medium? In case of acidic medium, H plus is present, and this H plus is common to this H plus. So the concentration of the ion in the right hand side will go on increase. So due to that, the direction of the equilibrium will be from right to left. So the condition will be colorless and acidic medium. So in case of acidic medium, the color of the phenolphthalein will be colorless, and in case of basic medium, color will be pink. Methyl orange, right? Methyl orange has pH range 3.1 to 4.4, and it is a weak organic base, and it is represented by MUS. Similarly, methyl orange works in case of acidic medium. The color of methylene orange will be red in case of acidic medium. So let's explain about this. In case of acidic medium, H plus will be present in that solutions. So due to presence of H plus, this OH minus and H plus combines to form the water, so that the concentration of OH minus in the right hand side will go on decrease. Then the direction of equilibrium shifts from left to right due to the difference in the concentration, because the concentration of MUOH is high and OH minus is low due to the formation of H plus and OH minus in water, and the color will be redder in acidic medium. In case of basic medium, OH minus will be present, and this OH minus will combine with this OH minus, right? So it does not combine, but here is a common ion effect, that is common ion, so that the concentration of OH minus in the right hand side will go on increase. So due to that concentration differences between the right hand side and the left hand side, the equilibrium shifts from right to left, and the color will be orange or in basic medium. So this is the main mechanisms of working of indicators during titration method. This is very important, right? Remember this. Next question. Acetic acid has molarity 2.05 molar and specific gravity is 1.03 gram per ml. Specific gravity is nothing, it is density. And molality is calculated by using this formula. Molality is equal to number of moles of solute divided by weight of solvent in kg. Remember, this should be solvent and this should be in kg. Then according to this molarity concept, 2.05 m of acetic acid means 2.05 moles of acetic acid in 1 liter of solutions. We have already discussed about the concept of molarity. Then volume of the solution is equal to 1 liter, that is 1000 ml. Then we have to calculate the weight of solvent is equal to weight of solution minus weight of solute. Then density of the solution was given, that is 1.03 gram per ml. So weight of solution will be 1.03 into 1000, right? We know that density is equal to mass by volume. Mass by volume. And mass is equal to density times volume. Where is the volume? 1000 ml. With 1000 ml is the volume of the solution. Then 1000 times the density of the solution gives the 1030 gram, that is the weight of that solutions. So we have to subtract weight of the solutions from the weight of the solute. Then weight of the solute is calculated by using molecular weight of acetic acid, that is 60 gram. Then weight of solute is equal to number of moles times the molecular weight. The number of moles is calculated by using formula mass in gram divided by molecular weight, right? Molecular weight. Mass in gram divided by molecular weight. Then mass in gram or the weight is equal to number of moles times molecular weight. So 2.05 mole is the, here is 2.05 moles of acetic acid times 60 is the molecular weight of acetic acid. Then 123 gram is obtained. Then weight of solvent will be weight of solution minus weight of solute, that is 907 gram. Then molality will be number of moles of solute, that is 2.05 divided by weight of solvent in kg is equal to 0.907 kg is equal to 2.26 mole per kg. Answer. So this question could be solved on the basis of this formula, right? This formula is also helpful for the calculation of this problem. This question is very important. When equal volume of 0.1 molar silver nitrate solution and 0.2 molar sodium chloride solution is mixed, the resulting concentration of nitrate ion, remember nitrate ion in the solution is, right? Here is the general reactions of the above problem. The initial volume of silver nitrate is let be, and the strength of silver nitrate is given 0.1 molar, and initial volume of sodium chloride will be B. This is assumptions, right? This B and this B is just assumptions because volume has not been given, but the question clearly told about the equal volume of silver nitrate and sodium chloride. Then strength of sodium chloride will be 0.2 molar. Here is 0.2 molar. Then we have to calculate the strength of nitrate ion in the mixtures. The volume of the resulting mixtures will be 2B, because 1B will be of silver nitrate and 1B will be of sodium chloride. Then the total volume of the mixture will be 2B. Then the strength of nitrate ion will be 0.1, right? Remember, nitrate ion will be furnished by silver nitrate only, right? Nitrate ion should be furnished by silver nitrate ion, because sodium chloride should not furnish the nitrate ion. In the question clearly mentioned about the calculation of concentration of nitrate ion. So 0.1 times B. B is the volume of silver nitrate divided 2B is the total volume of the mixtures. Then answer will be 0.05 molarity. Right. Very important questions. Next questions. What is the amount of 10 ml of 1 normal dibasic acid? Molecular weight is equal to 200. Right? We have to calculate the amount of dibasic acid, right, by using this formula. Normality is given, but we have to calculate this weight of solute in gram is equal to 1 gram. So equivalent weight will be molecular weight by basicity. Basicity is 2 because the acid is dibasic. Dibasic means basicity 2. So weight will be 1 gram. Simple question. 1 gram HCl and 1 gram NaOH are dissolved together in 1 liter solution of water. Then the resulting solution will be. We have to calculate whether the resulting solution is acidic, alkaline, neutral, or amphoteric, right? First of all, calculate the strength, right? Strength means molarity or normality, but in this case, molarity will be calculated. So strength will be number of moles of solute divided by volume of solution in liters, right? So volume of solution will be 1 liter in both cases. We have to just calculate the number of moles, right? Number of moles of HCl will be 1 by 36.5. This is the weight of HCl and 36.5 is the molecular weight of HCl. So number of moles will be weight in gram divided by molecular weight 1 by 36.5. Then strength of NaOH is calculated in the similar manner 1 by 40. 1 is the weight of NaOH and 40 is the molecular weight of sodium hydroxide. So 1 by 40. Then strength of HCl is greater than that of the strength of NaOH, right? 1 by 36.5 is greater than that of 1 by 40. So the solution will be acidic. Very important question. 18 molar solution of sulfuric acid was diluted to 100 liters. So find the normality of the solutions. So we have to calculate the normality of the solutions. Right? So normality of sulfuric acid will be 18 into 2 by using this formula, right? Because molecular weight will be 98 and equivalent weight is 2, then 98 by 2 is equal to 49. Then molecular weight by equivalent weight is equal to 2. So normality will be 2 times greater than that of molarity. So 18 into 2, 36. The initial strength will be 36. Then initial volume will be 1 liter. So let just assumptions. Then final volume is 100 liter because the solution was diluted to 100 liter. Then the final volume will be 100 liter. So by using the normality equations, answer will be 0.36 normality or normal solutions. Very important questions. You have to just remember this formula and we have to convert the molarity of sulfuric acid into normality. Next question, 0.5 normal concentration of 100 ml solution on dilution to give resultant solutions having 0.2 normal. What is the volume of water that should be added to the solutions? The concentrations of that solution is going to be decreased from 0.5 normal to 0.2 normal, right? So the concentration is decreased. So the dilution has been taken place on that solution so that its concentration has been decreased. So for the dilution we have to add water. So how much amount of water should be added? So the question is asked about the amount of water. So initial strength will be 0.5 normal, here is 0.5, and initial volume will be 100 ml, here is 100 ml. Then final volume we have to calculate, then final strength will be 0.2 m. Then by using the normality equations, answer will be 250 ml. Then 250 ml is the volume of the solution in final case. Then we have to subtract this volume from the initial volume to calculate the amount of water added, that is 150 ml. Very important question. A toothpaste contains 0.2 gram per liter fluoride, then its value in ppm, right? We have to calculate the value of 0.2 gram per liter in ppm. So here is the general formula of ppm: weight of solute in gram divided by volume of solution in ml into 10 to the power 6. 200 ppm will be obtained, and weight of fluoride 0.2 gram, and 1 liter means 1000 milliliter. Just use this formula to calculate this problem. The normality of solution containing 5 gram of NaOH per liter is, so we have to calculate the normality by using this formula, right? Simply use this formula and put the value, answer will be 0.125, and the equivalent weight of solute, that is sodium hydroxide, will be 40, right? Equivalent weight is equal to molecular weight divided by acidity in case of base, and here is acidity 1 because here is only one OH minus ion replaceables. Next question, molality, right? This question is very important and it is based upon the molality, right? We have to calculate the molality of the solutions by using this formula. 15% W by V solution is known as 15 gram of sulfuric acid dissolved in 100 milliliter of solution. Then the volume of the solution will be 100 milliliters. We have to calculate the weight of solvent in kg, and the density of the solution is given as 1.1 gram per ml. Then weight of solution will be 1.1 into 100. 1.1 is the density and 100 is the volume. So density times volume gives the weight, that is weight of solution will be 100, because m is equal to density into volume, right? So we have to calculate the weight, and weight of solute is 15 gram, here is 15 gram, then weight of solvent will be 95 gram, right? By using this formula, answer will be 1.61 mole per kg. Very important question. Next question, the amount of copper sulfate .5H2O, it is also known as blue vitriol, required for producing 500 cc of 0.5 normal solution is, right? Remember this formula to calculate the amount of blue vitriol, right? Here is weight of solute in gram, this means amount of blue vitriol. So molecular weight of blue vitriol is 63.5 is the atomic weight of copper, 32 is the atomic weight of sulfur, and 16 into 4 plus 18 is the molecular weight of water, 18 into 5, so 249.5. Equivalent weight will be 249.5 divided by 2. Why this is 2? Because the total positive charge present in copper sulfate, that is 2, Cu2 plus, Cu2 plus. In case of sulfate, SO4 2 minus. So total positive charge or total negative charge, right? Molecular weight by either total positive charge or total negative charge gives the equivalent weight. So 124.75. So just put this value in this equation, then answer will be automatically obtained. Right. Next question. When 100 ml of 1 molar H2SO4 is mixed with 20 molar cc of 5 molar NaOH, then the resulting solution is, we have to calculate whether the resulting solution is acidic, alkaline or neutral, right? So volume of H2SO4 given 100 cc. 100 cc means 0.1 liter, and strength of H2SO4 given 1 molar. 1 molar means 2 normal. We have already discussed about this relationship between normality and molarity. Then Na into Va, right? Na into Va gives the number of gram equivalent, that is 0.2 gram equivalent. In similar manner, number of gram equivalent for NaOH will be 0.1 gram. Then we have to compare the number of gram equivalent between these two cases, that is acid and basic case. So number of gram equivalent of acid is greater than that of number of gram equivalent of base, so the mixture will be acidic, right? Just compare the number of gram equivalent by using this formula, right? Na into Va, right? Na and B into Vb. If volume is in ml, then number of gram equivalent is calculated by NaBa divided by 100 cc, that is 100 ml. Next question, The concentration of cane sugar C12H22O11, it is also known as sucrose, which is isotonic solution containing 6 gram of urea. Isotonic means same concentrations, right? Same concentration of urea and cane sugar. Isotonic means same concentration. Molecular weight of urea is 60, right? Here is the molecular formula of urea, and by using this molecular formula, molecular weight will be 60. A number of moles of urea will be 6 by 60 because 6 gram of urea is given. Then 6 by 60 is the molecular weight, 0.1 mole. 0.1 mole of urea is present in 1 liter of solution. Let us consider just. Then the concentration of urea will be 0.1 molar because 0.1 mole is present in 1 liter of solution, means 0.1 molar is the concentration. So according to question, cane sugar is also 0.1 molar because cane sugar is isotonic to the urea, so 0.1 molar, and molecular weight will be 342 in case of cane sugar. Then gram per liter strength should be calculated is equal to molarity into molecular weight. We have already discussed about this formula because gram per liter is equal to molarity into molecular weight. Molarity is 0.1 and molecular weight is 342. So answer will be 34.2 gram per liter. Answer A. Important questions, right? Just remember this relationship, right? What is the normality of ammonium hydroxide solution having density 0.6 gram per ml containing 34% by weight of ammonium hydroxide? Just remember this formula to calculate the normality. Normality is equal to weight percent into density into 10 by equivalent weight, and put the value here. 5.82 normality is the answers, and we have to calculate the equivalent weight of ammonium hydroxide. It is 35.1. 35 is the molecular weight of ammonium hydroxide. By using this molecular formula, we could easily calculate the molecular weight of ammonium hydroxide, and 1 is the acidity, that is number of replaceable OH. Here is only one OH, so 35 by 1 is 35. Answer will be 5.82. Just remember this formula. If 4 gram of NaOH is dissolved in water and volume is made up to 250 ml, the concentration in gram per liter will be. We have to calculate the concentration in gram per liter. It is very simple questions. Just convert this 250 ml into liter. So 4 by 250 because 4 gram of NaOH is dissolved in water and volume is made up to 250. Then 4 by 250 into 1000 will give the answer in gram per liter. Very simple. 1 kg of water contains 4 gram of NaOH. The concentration of solution is best expressed as, right, molal. Here is molal because the weight of solvent is given in kg, that is weight is given in kg. So we know the definition of molality, right? Here is the definition of molality. Number of moles of solute divided by weight of solvent in kg. This is the definition of molality. And 1 kg of water, 1 kg of solvent is given. So it will be best expressed in molal. The number of moles of NaOH is 4 by 40, right? 4 is the weight of NaOH and 40 is the molecular weight of NaOH. Is equal to 0.1. Weight of solvent is given here 1 kg. Then answer will be 0.1 molal. So 0.1 molal. Next question. In the graph, the titration shows between. Here is a titration curve between the pH and volume. In y-axis pH is written, and in x-axis volume of the base added from the burette. And this is the end point of the titrations, and this straight line represent the sharp change in pH during the neutralization. So in case of strong acid and strong base, the sharp change in pH falls in the region of 7 because the pH of strong acid and strong base will be 7 in the end point, right? However, strong acid and weak base, the pH will be less than 7. In case of weak acid and strong base, pH will be greater than 7. We have to just notice about the strong. Which one is strong? Acid is strong, so pH will be less than 7. Then which one is strong? Base is strong, then pH will be greater than 7. In case of weak acid and weak base, no any sharp change in pH is found. So no any sharp change in pH. However, there is sharp change in pH, right? There is sharp change in pH in the region of 7, pH 7. So answer will be strong acid and strong base. In case of strong acid and weak base, weak acid and strong base, the graph will be in another type. So I will discuss about this graph strong acid, weak acid, strong base in another lecture. That is volumetric analysis part 2. We will discuss about this. Next question. When 50 ml of HCl reacts with 10 gram of calcium carbonate, the normality of the solution is. We have to calculate the normality of the solutions containing calcium carbonate in 50 ml of HCl. Right? Molecular weight is 100 gram. Right? Very simple. Equivalent weight will be 50, 100 by 2. Why this 2 is obtained? How this 2 is obtained? Then 100 by 2, right? 100 is the molecular weight of calcium carbonate divided by total either positive charge or negative charge. In case of calcium carbonate, total positive charge is 2. So 100 by 2, 50. So this is the calculation of normality for the calcium carbonate. Then answer will be 4 normal, right? Volume of HCl solution in ml will be 50 ml. Just put this value in this equation. Answer will be automatically obtained. You have to just remember this formula. 0.4 gram of sodium hydroxide is added to 10 ml of 1 normal HCl. Then the resulting solution is, we have to calculate the number of gram equivalent in both cases, right? Volume of HCl is 10 cc, that is 0.01 L. Then normality will be 1 normal, that is the normality of HCl, right? Here is not written, but it is the normality of HCl. Then number of gram equivalent of HCl will be 0.01 gram equivalent. Na into Va is the general form for the calculation of normality. The number of gram equivalent of NaOH should be calculated by using this formula. Number of gram equivalent is equal to weight divided by equivalent weight, right? Weight divided by equivalent weight. Weight of NaOH is given 0.4 gram and equivalent weight of NaOH is 40. So answer will be 0.01 gram equivalent. And in case of acid, 0.01 gram equivalent. In case of base, also 0.01 gram equivalent. So the mixture will be neutral because number of gram equivalent of HCl is equal to number of gram equivalent of NaOH. So mixture is neutral. Next question. 10 ml of 2 molar H2SO4 is mixed with 10 ml of H2O. Then 10 ml of mixture can neutralize how much amount of 2 normal NaOH? We have to calculate the volume of NaOH that can be neutralized by 10 ml of H2SO4 mixtures. Volume of H2SO4 given 10 ml, right? Strength of H2SO4 4 normal, right? Here is 2 molar given, so 2 molar is equal to 4 normal in case of H2SO4. I have already discussed about this. Then total volume of the mixture will be 20 ml. How this 20 is obtained? 10 ml of, here is 10 ml of water and here is 10 ml of H2SO4. 10 ml of water is added to the 10 ml of H2SO4 having concentration 2 molar. So total volume will be 10 plus 10, that is 20. 10 plus 10, 20. Then strength will be 10 into 4 by 20 divided by 2 normal. Here is 10 into 4 divided by 20. Just use the normality equation. Then volume of the mixture used is equal to 10 ml. Now this 10 ml of the mixtures of concentration having 2 normality, right, can utilize how much volume of 2 normal NaOH. Then volume of the mixture used is 10 ml. Here is 10 ml. Then strength of NaOH is 2 normal. Here is 2 normal. Then we have to calculate the volume of NaOH by using the normality equation. This 10 is, how this 10 is obtained? This is volume of the mixture used, and this 2 is the strength of the H2SO4 mixture, and this 2 is the strength of NaOH. So answer will be 10 ml. Simple.